Okay, so hello everyone. It is my great privilege to introduce my dear friend and very established investigator at Mayo, Dr. Davide Sottara. So it's not David, it's Davide. It's an Italian pronunciation. Davide, do you want to say it?
That's correct. That's perfect.
So Davide holds a MS in software engineering and a PhD in hybrid AI system from University of Bologna, Italy.
Bologna. Yep.
In Italian. He joined Arizona State University as a clinical assistant professor specializing in clinical informatics, transitioning to Mayo Clinic full-time in 2019. He took the role of the principal knowledge engineer for the organization's knowledge management program. And during this time, he also played a key role in developing model-driven applications for shared decision-making at the point of care. In his latest role within the office of the CTO, he leads a dedicated team focused on AI research and development, driving innovation in the rapidly evolving landscape of artificial intelligence. Let's welcome our brilliant AI researcher, Dr. Sottara.
Well, thank you all for having me. I'm very honored to be here today. So let me share my slides, and we should be good to go. Let me know if you can see my screen.
Yes, we can.
Perfect. So today we will talk about AI agents, something that has been called the third wave, something I kind of disagree with, having seen many more waves of AI. But the third big wave of artificial intelligence revolution, something that is predicted to be the next technology that will transform empowering our everyday life, but in our clinical, medical, health-related settings. Today we talk about how in this particular domain, what roles agents can play, the research my team is doing in trying to translate, apply this technology to our heavily health-centric environments, and then also talk about the challenges that come with that. Without further ado, let me make a disclaimer. These are my opinions, and despite sharing some of the work we're doing, I want to make sure we do not misattribute to Mayo Clinic what some of the more controversial statements I may make today. Starting with, what is artificial intelligence? Everybody knows and nobody knows. I looked up, I was looking actually for a word cloud. What happened in the last few years, couple of years, AI has become commoditized. And generative AI language models, ChatGPT, they have created, for the very first time, a wave of AI that has permeated society beyond research, beyond the geeky environments. One of my colleagues said that everybody and their grandma, and this is the first time that his grandma asked him, what is ChatGPT? And that's fascinating because as the latest wave of AI, what is AI? What is the latest promise of revolution, of transformation coming from AI? We have seen it over several years. First, it was expert systems, then it was rules, then it was processes, then it was ontologies, then it was machine learning predictive models, then it was bigger machine learning models, natural language processing. Every time there's been a cycle of innovation, a bit of hype, some ground truth realism, a lot of lessons learned that have enabled the next era of next generation of artificial intelligence systems. Large language models have been a recent one, and the next, the way we are riding now is the agent era. I'm assuming everybody in this venue knows what large language models have been able to do. They've been for the very first time, able to take a general purpose AI without necessarily being yet artificial general intelligence, because of the way the ingenious new architecture of the subsymbolic neural networks that build a language model, because of the ability to translate between symbolic and neural systems, because of the availability of huge data, because of some innovation in technology, computing power between the latest and greatest chips that enable massive parallel computing. For the very first time, we have what seems to be a general purpose artificial intelligence, an intelligence that is able to complete, to some degree of satisfaction, whatever that means, a variety of tasks. Previously, we always had bespoke, dedicated AIs. And for the first time, we have some general purpose AI. How it works behind the scenes, I'm assuming we know. It's really all about predicting next symbols in a sequence. It's all about completing sentences and then completing more sentences. In reality, the perceived behavior is that we have something amazing that is able to answer questions, provide insights. And what is question? What is language? We have been exposed to the multimodality of quote, quote, language models, models that can read and create images, produce sounds, hybridate, look at medical images and correlate that with medical records, structured and unstructured, and being able to suggest opportunities for diagnosis. It all comes down to what language is. Language is symbols organized in a way to convey and reflect concepts that exist within an intelligent brain. And the ability to generalize the notion of symbol is what has opened up the multimodalities and the ability to generalize behavior of these models. What these models do not do, or at least don't do yet, for all the vast knowledge that they possess, they're able to acquire throughout their training. For all the sizable amount of context they can be given with the prompts or the inputs or the instructions, they're able to make incredible inferences, incredible insights on that context. The one thing language models do not truly have is a state, a memory. Those of you who work with GPT-like applications probably would disagree to some extent with me. The model remembers you, but we'll get to that in a moment. But the point is, language models can be instructed to learn in context, acquire from the context the instruction, the information they need to short-term complete a task they've been given. But there is not that last bit of memorizing, acquiring, retaining what has just happened. I sometimes think of a language model as your forgetful expert, omni-skilled consultant. You can always call, you can always explain to them what the problem is, and they will give you the most insightful answer. You call them again next day, they will not remember who you are. And by design, to some extent. How do we go beyond this limitation? How do we transform something that's on demand, on call, to a more active participant in a complex scenario, so that the activity these models can now drive, instead of being asked to supplement, can help collectively steer us toward achieving a goal? And the goal, especially in healthcare, is ultimately improve the health of the people we care for. I use the magic word acting, and that's where agents come in. Agents is not a new concept. Agents have been designed since the and conceived since the very early ages of AI. What we have today is general AI, generative AI powered agents. This is what made us leap, revitalize, revamp an old idea, the apex of artificial intelligence, make it feasible, make it possible, make it easier, make it more scalable, more efficient, more effective. What makes an agent that just an intelligent does not have? The ability to interact. Agent comes from Latin, of course, Italian, as I am, my Latin roots. The idea of acting is key. To have an agent, you require the ability to interact with the environment, to sense and act, the control theory of worlds. Acting can be communication, can be actual acting, side effectuating something on the environment. But at the end of the day, number one, the ability to be plugged into an environment. And number two, even more important, in all fairness, there are different kinds of agents, but the agents we're looking at are the ones that have intents and goals. The end and the means, and a plan, which is a way, a mechanism, a recipe, if you want, to, given the current state of the environment, given the goals that the agent may have been given or may have developed itself, conceive a plan, a way to achieve those goals when those goals are not met yet, being intentional about it, and with intent acquiring missing information, sharing information that can be needed by other participants in the environment, and ultimately, if needed, take action themselves. You could conceive that what is missing, if an LLM is the brain, the agentic is the, bear me if I use that word, the soul. The ability to interact is the body. And in fact, agents are very much bridging robotics. We will not talk robotics today, but will be the next connection into the two big areas historically of artificial intelligence, control theory, and information processing. That said, what makes the soul, the intelligence of the agent? There is this referential foundational paper, the Koala architecture, which focuses on the big missing element I called out in LLMs, which is the contextual memory. Of course, LLM have vast long-term knowledge acquired through their pre-training. What makes an agent is the ability to retain information about their environment, their context, in between autoregressive self-feeding sessions. We distinguish all the kinds of information that an agent would be able to or needing to memorize from the shorter working memory. This is the context that the agent has been passed, the conversations you may have with the agent, all the contextual facts that may have been fed to the agent in order to leverage the LLM reasoning capabilities. But then we have the long-term memory. And in the long-term memory, we have, going right to left, the episodic information. An agent would be able to remember interactions with the environment and or the users, interlocutors, across sessions over longer period of times. This memory, working memory and episodic memory, is what we have seen exposed in most commercial chatbot applications, which allow the chatbot to resume a past conversation, maybe learn something a bit about you. People could say profile you, depending, but gather that information to be able to better know who you are, what your client user goals are, and be more personal, be more individualized, be more even compassionate. If you're a patient that is interacting with a chatbot, trying to alleviate some of the clerical burden of your care providers, there is an absolute benefit in having that awareness of who you are, so that the model, which models are really good at, can talk to you in a more personalized way.
David, if you don't mind me interrupting for a second, is there a certain threshold of what would be classified as an agent? If it's perception, does it have to have a certain level of like the short-term memory or anything else? I'm just curious about that. And
I will get to that in a moment. That's a fantastic question.
Perfect. Thanks.
There is the semantic memory. This is the kinds of things you would not, your knowledge bases, your background information, the kind of information you would look in a textbook if you were a human. And of course, textbooks are the electronic equivalent, are always there. An agent that uses over and over and over the same kind of background knowledge may actually try to retain it so that it's more readily available, more consumable, even at some point committing it to its sub-symbolic. This is where fine-tuning and learning in context happens. And then the procedural memory, what to do to achieve certain goals. Task and plan, that's truly, in my opinion, what adds the apex of agenticity, the ability to have goals and have pathways to achieve those goals. At the high level, the plan; at the atomic level, the individual actions, the tasks. Given the question, I will hint that different agents or agentic entities have different combinations of different elements of this architecture, meaning this is a framework you can use to describe anything that would qualify as agentive. What happens in practice, different agents, quote, quote, have different degrees of presence, complexity, depth of any one of these elements. We don't have the time today, but episodic memory, how granular are you? Can you remember every single interaction, or would you lump them together in a single, I remember these settings. The tasks, how precise, how detailed, how fastidious are you in your description and consumption of a task instruction versus giving high-level guidelines. It all comes down to a measure of agenticity. When I first read this blog, I fell in love with it because it is spot on. Especially in the era of commoditized AI, some terms, for good and for bad, have been made more friendly at the cost of a little bit of precision. We end up calling agents or not agents a lot of things. Agenticity is a measure, is a degree. Any piece of software, an interface, human or technical, you interact with that can solve a problem you give them is an agent. What makes an agent is the ability to be triggered and execute a process to achieve a goal. How that happens, that's where the degree of agenticity comes in. A piece of software, that automation that reacts to an event and executes a certain series of tasks, computation tasks or control tasks, that can be considered an agent. Is it an intelligent agent? Probably. Is it a generative AI intelligent agent driven? No, it isn't. It's something that has been programmed, maybe even in purely good old procedural software, to achieve a goal. At the complete other end of the spectrum, we have an LLM which, properly instructed, is able to itself self-prompt to determine its goals, self-prompted to acquire the information or focus on the information it needs, self-prompted to come up with an execution plan and go ahead and execute it. That's an autonomous agent, which is basically independent. We're not fully there yet, and this is the part where AGI comes in with some concerns about ethics and trust, but we'll get there. In between, there is a spectrum. There is essentially three components. It all goes back to how much the agent gets its instructions from its programming versus the ability to adapt to the environment and rely on those instructions as a guideline, but then adjust, adapt, adopt to better fit the contingent goals that could not have been predicted at design time versus complete autonomy. The program is a meta program. You agent understand the problem you're dealing with, understand your environment, come up with a solution and run with it. Oof, pretty advanced. In fact, what constitutes the key component of agentry, the process plan that is able to achieve a goal given a state that does not satisfy the goal, needs action, and a trigger that is needs action now, is this plan. Speaking of community communal terms, these are often called graphs. I personally disagree with the term because they are nodes and edges, but they're task network graphs. And what these are plans. Plans that an agent can follow over time, multiple steps to achieve a goal. It's interesting from a clinical informatics perspective because plans in clinical AI have been the holy grail of decision support, I would say forever. Guidelines, clinical pathways, care plans, clinical protocols, care process models, institutional policies. They all, to different degrees of normative enforcement, they try to enforce behavior for standard of care, sometimes at the cost of a little bit of lack of individualization, but ensuring that medicine is practiced in a way that respects usually the evidence behind it, as well as the resource constraints, as well as the patient preferences. The great opportunity we're seeing here is that up until the advent of general purpose generative AI, one way or another, more or less sophisticated, the plan component, so the computable practice, guideline process, decision support, all of that informatics was always essentially programmed. Was model-driven, was low-code, was smart, was knowledge-based. All great. That has not gone away, but the part that has always been challenging, the last-mile adaptation, the care delivery, the setting-specific factors, I'm quoting my mentor, Bob Greens here, that adaptation has always been a big problem. What generative AI empowered agents can do is they don't need to figure out that part at the same time. They have the ability, the opportunity, and the risk of knowing at runtime, at action time, in context, what the situation is, and within the boundaries of the more or less prescriptive plan they have been given, figure out how to adapt, how to react, reason, act, agent pattern, to execute that plan, but make it in a way that satisfies the contingent constraints of the context, and context rules. All you need is context-ish, is where agenticity comes into play. In my opinion, to answer the question that was posed, what makes an agent, and then there's degrees, is this ability to have a plan. Oftentimes the plan is given at design time, but at least some ability to adjust the plan based on that day patient mood, the availability or not of a certain resource, the clinical setting, or any one of those context factors that may need that readjustment, rethinking, re-reasoning that the generative AI component intelligence can do and feed it back to the execution loop. Of course, when it comes to acting, one thing is to acquire information, one thing is to process it and generate data, whatever, who cares? The moment that information is fed back to an environment and actions, decisions, even communication is given back to a human being, there is a huge ethics, social, economical, even moral problem. And especially with hallucinations and other still known issues of the modern generative AI, there is always a risk that something may not be adequate, may not be appropriate. So a key component of agentic architecture is the notion of guardrails. They've been introduced before. I know Dr. Hart mentioned them. A guardrail is a control that checks what is given to the LLM. Am I being asked to do something respectful? Am I being misled? Am I being even scammed in a certain sense? And the post guardrails, as an LLM, I've made my decision, I'm trying to follow my plan, I'm trying to act. Is it something safe, reliable, doable, feasible, legal even for me to do? Guardrailing, empowering agents with guardrails is almost a mandatory element to ensure that the agents are safe. Because of the general purposeness of generative AI, you can ask an LLM to answer any kind of question, and most of them, some of them, will try. Should they? And if they do they do it properly? These guardrails are ways to make sure that this intelligence does not go astray. Especially because when we go from one agent to many agents, and when some of those agents are now people, we go from old school AI, which was more delivered through applications, software interfaces with human-computer interaction, to the communicative natural language interfaces of language models, to the interactive multimodal artificial agents, if not robots, that can interact with a person or each other. Now we have a multi-agent system, a socio-technical system where some of the participants are human, some are not, and they collaborate. This notion of agentry has been there for a long time. What is happening nowadays with generative AI, it is becoming reality and it is becoming scaled. We will see more of these agents in our everyday life, and we need to be able to trust, to rely, and make use of them properly. Evaluation then becomes key. And in software, we have had QA for a long time. In AI, we've had statistical validation techniques, all that machine learning has taught us. With generative AI-powered agents, it is my belief, and not only my belief, quite a few people agree with me and some don't, that the way to evaluate these language model-powered agents is human resources. You have to treat this intelligence as your colleagues. Talk to them, challenge them, see their performance, and see what tasks they're good at. General purpose AI means sometime an agent will be able to execute certain plans, may not be able to execute different kinds of plans, and maybe that one day, even if it's a task they've done over and over, probability of random sampling, there's a failure. So the more and more these agents are deployed in safety critical environments like a clinic or an ICU or an OR, the more we need these technical and social guards that puts check and balance in what an agent is doing at that time and what an agent has been able to do over time, and then use feedback techniques to correct, fine-tune, train the machine learning models that constitute the agent to ensure that the agent performance is effective. And effective comes into ethically, clinically, socially, legally safe. Of course, with all these problems and all these solutions being pushed to us from all the technology enthusiasts that are willing to help us build these things, what are we actually doing? We are in a clinical environment. We have this grand vision, the ability to translate our old AI dreams into reality, very complex clinical, clerical, administrative problems. Can we solve them? And this is where things get complex. Language models, in essence, ask questions, answer questions. The next immediate everybody is doing it kind of solution is, well, let's solve the hallucination problem. Let's empower these language models to not only rely on their pre-trained knowledge, but also to get context that they may not have seen or may not be focused on. Let's give them context. Enter RAG, Retrieval Augmented Generation. We augment the language model with in-context information that machinery, a sort of tooling pipeline acquisition mechanisms, allow to make sure that the intelligence is given, to be fair to them, the right information, the right context they need. We call it vanilla RAG because it's the very basic assumption. We got a smart pre-trained knowledge, we got our context, let's give it to it and it will come up with the right answer. Sure, true in a very small focused domain, but what happens when the complexity scales? We have multiple contexts, settings, personas, we got multiple topics, discipline, specialties, we got multiple sources, some of which are trusted, we got multiple audiences, we got multiple intents. The complexity of the search space, cursor dimensionality, starts to grow, and even a very smart intelligence starts to a problem of information dilution. There's too many directions to go that could be easily lead to or mislead to an unwanted outcome. Vanilla RAG is the basics. There are papers that describe a vast number of refinements to retrieval augmented generation. One of them, one technique is agentic RAG. Why don't we make retrieval augmented generation the plan of an agent so that the agent can be more aware, more deliberate, more intent and goal-driven in the kind of information it retrieves and processes. So one pattern, this is one we are exploring with my team, is a self-reflective, critic-enabled RAG agent. We put guardrails, and when a question comes in our clinical chatbot, is this a question we can answer? Is this an easy question and can answer legally and ethically? If it is it one we can feasibly answer? Do we have the data? Do we have the context or not? If not, we don't answer. Don't even try. If we do, maybe it is an answer with a question we've answered before. So why bother? Let's answer over and over. Maybe it is a new question that does need to look up and retrieve the right kind of information. And maybe there isn't only one place, there's several. So Our RAG process can be broken down into sub-processes where we go and acquire some medical record information, some medical policies, some scientific literature, and all those streams map produced get back into the hands of the main agent, who now has to critique and say, is this information I can use? Is it trustworthy? Is it pertinent, meaningful? If so, use it. If not, drop it. And then with that, generate a response. And because who knows if that response is appropriate, use a self-critique mechanism to say, is it a good response? Is it one we can offer to whomever asked the question, or is it something that needs a refinement, a review, up to, starting over? The agentic component here is the plan. There's several tasks, each one of which is complex and possibly requires intelligence. The goal, answer the question, and the intent to answer the question properly. And if any of those steps fails, the stateful nature of the agent is keep trying until you either succeed or apologize and fail. Of course, this has a very practical clinical application because the kinds of questions we get sometimes are about PTO. How do I compute my PTO balance? Sometimes are clinical in nature. And a lot of clinical workflows can be formalized, interpreted as answering clinical questions. And what we have noticed is not all questions are equal. And some are very easy and trivial. Some are a bit more complex because they require more data. Some are even more complex because they require clinical insight and moral and emotional intelligence. Something we worked with in the past and now has revamped is the ability of taking not only execution plans, but also problem-solving plans. We used to call them decision models, other standards, and decomposing big problems into smaller problems and having this become an information processing plan that is now internalized, executed as a plan, but for the sake of making a very, when the case is we have a very complex question to answer, break it down into more sizable, verifiable, trustable, evaluatable, critiquable, I'm making terms up now, questions that can be answered and then recombined. The good old backward chaining of reasoning systems, right? And agenticity adds the ability to say, back to the agent who's able to critique the complexity of the question. Is this a complex question? Is it a complex question we can answer because we already have the data? Maybe we answered it before. If so, we're good. Is it a question that we need to decompose and either come up with additional context information to answer that question? Or is it truly something we have to break down and then reassign? In this example, which some of you probably have recognized as a more lifted variation of the Hasblad score, the clinical interpretation, not the poor man predictive model, poor man but very effective, to be fair. The ability to assess the benefit risk of anticoagulation, very highly complex problem that depends on management decision, patient preferences, and pathophysiological status. Sometimes that question has been asked by and answered by a clinician. And if the question is asked again, the problem is going back to the medical records and find what the decision was. Simple retrieval problem. Other times the question has not been asked before, and now we have to go after very complex sources of information. This is to say that the complexity of answering a clinical question, which is a key element of clinical applications of agents, in part depends on the question itself, its risk, its depth. In part depends on the data and knowledge that is available to the agent at the point in time the question is being asked. And closing that runtime gap is where the adaptivity, the adaptiveness of an agent's replanning comes into play. If that question is simple, answer it. If it is complex, but we have the data, so it looks complex, but it's simple, do it. If it's complex and we do not have the data and the knowledge, can we get it? Can we use it? Let's apply it. Else, keep falling back, adjust the plan, adjust your strategy until you can figure out a way to solve the problem, navigating the complexities of your context, which may not have been known, probably could not have been known or predicted at design time. And this is where we have techniques and technologies that we build into the agents for that self-critic component. Rag checker is one of many examples. There are really two problems here we're trying to face. One is, can we give that agent the self-insight it needs to determine whether or not the goal it's going after has been achieved? If so, done. If not, keep executing the plan or replan. That's the internal insight used to execute through the plan. And then we have the after the fact critic self-evaluation. Am I confident? Am I right? Can I hand this answer over to whoever asked me? And this is where the evaluation frameworks of the output more than the process come into play. And we're looking at technical, linguistic based quantitative approaches, but also social approaches. Trust, human feedback, prediction of impact, as well as social technical approaches. Can I talk to the agent and make sure that it is confident? Ask it to self-evaluate, have another agent evaluate the other agent, so more of a critic, supervisor, all kinds of approaches that require state and division of labor that a single LLM alone, despite all the chain of thought prompting you can imagine, cannot quite do reliably and scalably. Last but not least, so far we've outlined the ability of an agent to come up with a plan to generate answers, create new information. What if we want to go beyond that? How much beyond that is beyond that even to begin with? Agents can act. Should they? Do we want them to act? What kinds of tasks do we expect agents to do beyond answering questions, which of course we expect? From a clerical administrative burden standpoint, we are definitely looking at automating some of the easy parts. Communication, administrative workflows. But agents could go way beyond that. And now what is in part a technical challenge and opportunity is more and more social, ethical, legal challenge. Yes, IT has some issues to deal with, but when it comes to agentry, and especially agents with side effects that do interact with the environment, guarding, predicting, preventing, accepting, recognizing, acknowledging, cheering for activities that these agents can do is going to be more and more similar to the way we treat colleagues, friends, employees, consultants, other humans. then we treat technology. And the question is, when, where do we want it? And I do not have an answer for that.
Davide, since we are near the end of hour, I just want to make sure everyone has a chance to ask a question. Or are you toward the end, or should we pause for some questions?
I'm toward the end. I have like 2 slides and I will be done.
Oh, okay,
Yes.
okay, that's fine.
Appreciate it. Thank you. So at the end of the day, what we're going towards is potentially, it's possible, again, not necessarily desirable, to go from large language models that have transformed our lives to chatbots, which we see over and over, to agents, which we can start to plug into our social lives, to a socio-technical hybrid society where humans and AIs will one day potentially cooperate. How far are we in this journey? Well, we are here in the age of chatbots with a few tentative approaches to assistance. Is there a huge opportunity and a huge risk? Yes. And what I'm calling for is the fact that we are shifting. Technology is great. It gives us the ability to do things we wanted and could not do before, but is shifting the problem from being a technology efficient cost problem to a more social, moral, ethical, normative problem. And we will see more and more of these switches from a technology-oriented problem to a socio-technical oriented problem. And with that, I'm done with my presentation. I'll be happy to open up the conversation.
So Davide, you can stop sharing because I'm seeing myself.
Sorry. Sorry about that. Thank you.
David, if you don't mind me asking, so where do you think are the greatest opportunities in health right now? Is it, do you think, on the operational side? Do you think it's on the decision-making sides, and maybe where the risk-benefit is given sort of, and I know this is, you could answer this probably differently on Monday, but I'm just curious.
It truly is a risk benefit. We are seeing a lot of opportunities in the safe space, information retrieval, pre-processing. So the R part of RAG, that is going full scale. We have too much data that for humans to process at this point in our digital medical lives. So the ability of intelligence to sort through that is absolutely something we want, because if not, we would miss the opportunity completely. And looping that in a system where it's the human who's always judging, reviewing, critiquing is a big win for low risk kind of situation. Automation, where automation was already in place and we can make it better, more flexible, more scalable, is also another big low risk, high return on investment. We see this as administrative burden lightening. We're not trying to take away jobs. We're trying to make people more efficient at doing their job in a more relaxed, empowered way. Anything beyond that, when it comes to problems that have ethical, social, legal implications, that's where we really need to take a pause, because this intelligence look like they can do it, but should they? And this is where I believe our translational research will come into play. Enabling the AI to plug back into the loop of the clinical, medical, social environment is where we need to be. One example comes to mind, answering patient portal emails, reporting back to the patients on their concerns, or reporting on the care that was given to them. We have seen ourselves that a lot of times there's not enough manpower to talk to the patient in the tone that the patient needs, because your documentation is made by clinicians for clinicians, and now you have to engage the patient. There's not enough resources in healthcare to engage all the patients to the level of care they would need or expect in some cases. So there is an opportunity to have AI help with that, but there's a huge risk. What if you tell the patient the right piece of information, you scare them, you mislead them? What's going to happen? One of our projects was about patient engagement, and I'll be honest, it's still being worked on because of the desire to alleviate the demand that we cannot meet, but also the risk. It's, I'll be honest, as a technologist, technology is not the problem these days.
Yep, that makes sense. Well, thanks for that.
Yeah, so may I ask a question? Yeah, thanks a lot for the nice presentation, David. It's actually just depending on the time, but my first question is actually double tap a little bit on the safe part you talk about, right? In terms of pre-processing information, retrieving information, and so on, which seems more practical these days, right? So could you give some more concrete examples of what kind of domain or tasks is kind of like we can potentially more safely apply these kind of like LLMs in the biomedical or healthcare domain?
The information retrieval piece is clearly the lowest hanging fruit. You have these questions asked. Natural language interpretation understanding has given the LLM the ability to ignore the noise in how a question is presented, identify the core concepts, and then pre-trained knowledge graph support allows to expand those queries. So you ask for, am I at risk of diabetes? Okay, diabetes is your key concept. You expand diabetes to the comorbidities, the medications, the labs, the vitals. You put the situation model around it. I'm talking SNOMED here. You got your time frame, your persona, your relationship. All those concepts that now are embeddings. I use embeddings as the mapping from the natural language into the concept space of LLMs, right? Vector-based retrieval allows to identify the pertinent sources of information across all modalities: clinical notes, structured file records or structured documents, clinical databases, clinical knowledge bases like drug knowledge bases, your ontologies, your images, multimodality. You're able to retrieve all this vast amount of information, but not as vast as your entire medical record, right? You have all and only the pertinent information. Hire a call because you use that query expansion. Now the next step is go for precision. So of all the things that are potentially pertinent, what can we rule out as not pertinent? As Pareto dominated, this note tells me all and everything better than this other note. This process identifies the valuable pieces of information that now get chunked, sliced, diced, focused. So now you have all and only not the data, the information and the context that you can feed to your reasoning agent. Your agent may need additional knowledge, so you may do another meta retrieval for not the contextual particular information, but more your papers, more your evidence. Now you truly have your big context window full. That's when the LLM does its thing. Prompt is important, chain of thought, logic of thought, argumentation hints. You are logicians trying to make sense of conflicting information. You're a clinician trying to interpret this medical data. You are a careful thinker that only makes informed decisions. All of that to try to steer the reasoning process, and then you have the answer. That you feed to the critic. And the critic comes up with quantitative numbers, all your blue, rouge, meteor, all your scores. you have your LLM as a critic that also qualitatively, usually a different LLM, don't want to self-feed your own dog food, gives you a qualitative evaluation, and finally, human feedback in the loop. Hopefully, you have enough guards in place to prevent hallucinations that may be harmful. You can never rule them out with a probabilistic system, but you do everything you can to try to get to the best possible answer.
Got it, got it. Yeah, thanks for the detailed answer. Yeah, I have other questions, but I will leave other people to speak first. I don't want to,
Dr. Bora, you have a hand raised.
Thank you. This is really good. And this is more like a comment. So seems like not in healthcare, but I didn't know the sort of language at the time. So recently I listened to a podcast from New York Times. So they have a podcast on modern love. So they were apparently describing there's these two apps, ICE, ICE, and RIGG, RIG. So apparently in this, I mean, it's what you describe is that's exactly what happens. So that those particular apps, they create your clones, and your clone would be going out there, and then it would be dating with the clones of other sort of other and then they would essentially give you a summary. They would score the conversation and then give it to you, like because you are a very busy person, you don't have time to date, and then essentially in the evening you can look at the scores, and then you kind of sort of decide whether you as a human being kind of want to pursue the person. So I guess my point there is that maybe it seems like there has been some activity going on in other areas.
Oh, there indeed has been, and definitely areas that are of low risk, areas where you're not going to harm anybody. The barriers, the risk is lower, so advancement have been made without the regulations, the care, the guardrails that are needed in healthcare. So clearly. The other feedback I would say is having some of this background lets you judge, because at the end of the day, when you see a chatbot interface, who is behind it? Maybe there's the fake machines of the good old days, an actual human answering you. Maybe there's a simple language model. Maybe there is an agent. Maybe there is a clone of a very particular expert who's answering on behalf of that particular individual. I think what we need to do as consumers of these applications is get a little bit more smart in understanding what's happening behind the scenes. Is this a good one? Is this one I can reliably trust? Is it robust? How far can I challenge this human interface without breaking it deliberately, the attackers, or without involuntarily causing it to tell me something that is harmful, like adding concrete to my lasagna recipe. Those are the things we really need to be aware of, especially when the model is, I don't have the knowledge. I'm invoking the model to get the knowledge I'm lacking. Otherwise, why would I be asking a question to begin with? But since I do not have the knowledge, I'm not able to judge myself if the answer I'm getting is good. I've been asking food and programming questions to LLMs, domains in which I do have knowledge. And I can tell that, yeah, I can spot some hallucinations I would not be able to spot in a medical setting because I don't have that same background. So again, when LLMs and agents come out as very confident, we need to be able to reflect that confidence they have in the trust we have in them.
Thank you.
Yeah, thanks, Davide. And now we are at the top of the hour. And thanks, Vishal, thanks, Dr. Ma, and thanks everyone for the great discussion. And I will see everyone next month. Bye.
Absolutely. Feel free to email me if you have any other questions or want to connect. Otherwise, thank you for having me. Appreciate it.
Thank you.